All right, in this video, we're going to talk about suggested homework exercises from 2.1, and I'm going to need a lot more whiteboard space this time, and I don't think I'm going to need the calculator. So we use the full screen here for the whiteboard. Let's go ahead and find the slope of the tangent line for f of x is equal to 3 minus 5x at the point -1, 8, and since they gave us the point, let's go ahead and find f prime at -1 using limit as x goes to -1 of f of x minus f of c over x minus c. F prime of -1 is limit as x goes to -1. 3 minus 5x minus 8 is -5 minus 5x over x plus 1. F prime of -1 is limit as x goes to -1 of -5 times x plus 1 over x plus 1 is f prime of -1 is equal to limit as x goes to -1 of -5 is -5. That makes sense. It's linear. Its slope is the same everywhere. So just finding the slope of the tangent line, we don't need to find the tangent line itself. So let's look now at number 13. 13 says f of t is 3t minus t squared at 0, 0. So f prime of 0 is limit as t goes to 0 of 3t minus t squared minus 0 over t minus 0. F prime of 0 is limit as t goes to 0 of t times 3 minus t over t. The t's will cancel there since it's getting close to 0 but not getting there. F prime of 0 equals limit as t goes to 0 of 3 minus t. So f prime of 0 is 3 minus 0 is 3. So the slope of the tangent line at 0, 0 is 3. Let's look now at number 17. They want us to use the limit process to find the derivative. So f of x is equal to -5x. So f prime of x is equal to limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. So f prime of x is equal to limit delta x goes to 0, -5x minus 5 delta x plus 5x over delta x. And these terms zero each other out. F prime of x equals limit as delta x goes to 0 of -5 delta x over delta x. Those cancel. F prime of x equals limit as delta x goes to 0 of -5 is -5, always, all the time. Let's look at 21. F of x is equal to x squared plus x minus 3. So f prime of x is limit as delta x goes to 0, x plus delta x squared plus x plus delta x minus 3 minus x squared plus x minus 3 over delta x. F prime of x is equal to limit as delta x goes to 0, x squared plus 2x delta x plus delta x quantity squared plus x plus delta x minus 3 minus x squared minus x plus 3. All of that is divided by delta x. So x squared minus x squared, x minus x, negative 3 plus 3, all zero each other out. F prime of x equals limit as delta x goes to 0 of 2x delta x plus delta x quantity squared plus delta x, and that is divided by delta x. So f prime of x is limit as delta x goes to 0 of delta x times 2x plus delta x plus 1 over delta x. Delta x's will cancel. F prime of x is equal to limit as delta x goes to 0 of 2x plus delta x plus 1 is 2x plus 0 plus 1 is 2x plus 1, and that's correct. Let's move on now to number 25. If you didn't get all that before I cleared the board, just go ahead and rewind the video. You can slow it down. You can pause it. That's the great thing about videos like this. I try to clear the problem pretty much right away to make the video as short as possible. But if you missed something, then go ahead and rewind, pause. You should be able to do that. So f prime of x is limit as delta x goes to 0 of x minus 1 minus x plus delta x minus 1 over x minus 1, x plus delta x minus 1, and then times 1 over delta x. So f prime of x is limit as delta x goes to 0 of x minus 1 minus x minus delta x plus 1 over delta x times x minus 1 times x plus delta x minus 1. So x minus x, negative 1 plus 1. F prime of x is limit as delta x goes to 0 of a negative delta x over delta x times x minus 1 times x plus delta x minus 1. And delta x cancel. F prime of x is equal to limit as delta x goes to 0 of a negative 1 over x minus 1 times x plus delta x minus 1. So that's a negative 1 over x minus 1 quantity squared. When I put 0 in for delta x, I get two factors of x minus 1 in the denominator, so I'm just going to write them with an exponent of 2. Let's look at number 37 next. And we want to find the equation of the tangent line now, given some information here about our function f of x. That is quadratic, negative 1/4 x squared, and a line that is tangent that is parallel to the tangent line. So if I solve for y here, then I get if x plus y was equal to 0, then y is equal to negative x. So my slope of my tangent line is going to have a slope of negative 1. Since it's parallel to this line, they're going to have the same slope. So this is f prime of x. I wish I could just use my rules that we learn later in this chapter, but we only know the limit process here. So limit delta x goes to 0 of negative 1/4 of x plus delta x squared minus the original is going to be plus 1/4 x squared divided by delta x. So f prime of x is limit delta x goes to 0 of -1/4 of x squared plus 2x delta x plus delta x quantity squared plus 1/4 x squared over delta x. F prime of x is limit as delta x goes to 0 of -1/4 x squared minus 1/2 x delta x minus 1/4 delta x quantity squared plus 1/4 x squared over delta x. This term and that term zero each other out. F prime of x is limit as delta x goes to 0 of, let's pull that delta x out, that's common now, -1/2 x minus 1/4 delta x over delta x, and those will cancel to give me a 1. So f prime of x is equal to limit as delta x goes to 0 of -1/2 x minus 1/4 delta x. This is -1/2 x minus 0 is -1/2 x. I agree with that. That is my derivative. So now I need to find the x value where this happens, that -1/2 x. My slope generating function is equal to -1, which I know from the slope of that parallel line. So I'm going to multiply both sides by -2. And I get x is equal to a +2. So f of +2 is going to give me -1/4 times 2 squared is -1/4 times 4 is a -1. So I have the point 2, -1 on the graph. Y minus a -1 is equal to an m that was -1 times x minus 2. So y plus 1 equals -x plus 2. Subtract 1 from both sides, and my tangent line is y equals -x plus 1. Let's look now at number 39, which will be a similar problem. If f of x is equal to x cubed, and I'm given the line 3x minus y plus 1 equals 0, y is equal to 3x plus 1, and my slope that I'm interested in here is going to be 3. My f prime of x is limit as delta x goes to 0 of x plus delta x quantity cubed minus x cubed over delta x. So f prime of x is, and you can use Pascal's triangle for this if you don't have the binomial theorem memorized. Delta x goes to 0 of x cubed plus 3x squared delta x plus 3x delta x quantity squared plus delta x quantity cubed minus x cubed over delta x. And the 0 f prime of x is limit as delta x goes to 0 of delta x times 3x squared plus 3x delta x plus delta x quantity squared over delta x, and these will cancel. F prime of x is limit as delta x goes to 0 of 3x squared plus 3x delta x plus delta x quantity squared. So that's going to be 3x squared plus 3x times 0 plus 0 squared is 3x squared plus 0 is 3x squared for my function, and that's correct. And so 3x squared needs to be equal to 3, X squared needs to be equal to 1. X can be equal to -1 or 1. So I'm going to have two tangent lines to find here. So case 1 is going to be f of -1 is -1, and my slope is 3. So y minus a -1 is equal to 3 times x plus 1, because minus a -1. Y plus 1 equals 3x plus 3. Y equals 3x plus 2. And then case 2, f of 1 equals 1. So y minus 1 is equal to 3 times x minus 1. Y minus 1 equals 3x minus 3. Add 1 to both sides. Y equals 3x minus 2. So I have two different tangent lines for that problem that will have a slope of 3. Next problem is 43. And we're just supposed to sketch the tangent line. If we have a linear function that goes through 0, 0 like this, actually any linear function like this with constant slope, as long as it's not vertical, then we're just going to have the tangent line will be the function itself. So you can just trace right over top of that here for the tangent line if you would like. That blue line is f prime. For 47, we're going to at -2, we're going to have a vertical asymptote. At +2, we're going to have a vertical asymptote because we're tending towards vertical tangents here and here. The slopes are positive over here, that these have positive slope. So it's going towards a positive infinity as we go over there towards the left. So this is going towards positive infinity as I come at -2 from the right. And at 0, we have a horizontal tangent with a slope of 0. So we're going to go through 0, 0, and then we're going to tend towards negative infinity over here. And this looks like a tangent function. To me, but it's showing the, instead of a tangent function that rises to the right like this, it is a negative tangent that I've multiplied the y values by -1 so that the y values are positive and the slope values are positive in quadrant 2 and negative in quadrant 1. So there you go. That looks right to me. 49, you can have different answers for 49, but I'll give you a couple examples. The easiest example I can think of a graph that's derivative is always going to be negative is a linear function with negative slope. I can also think of a exponential decay function, and there's other functions that you might be able to think of, like this type of a graph that's related to the log, maybe log base a of -x. This would be a to the -x. This would be something like y equals -mx. right? Or equals mx, where m is less than 0, right? I guess you could say. So here a is greater than 0. A is greater than 0 here. And a is also not 1. Okay. Is that the last problem? Nope, we've got a few more. So that was 49. Let's go down to 59. Writing a function using derivatives. So we have a 0.02 that's on the graph, and we have a slope that's constant of -3. So I can write the equation of the function y equals -3x plus 2, since I have the slope and the y-intercept. That one's pretty straightforward. Let's look at number 64. Now be careful, because this function is the graph of the derivative here. It's not the original function. So at 0, it looks like we have g prime is -3. At 3, it looks like we probably have a value of 0 right there for an x-intercept. What can we conclude about the graph of g, knowing that g prime of 1 is -8/3? The function g is decreasing at x equals 1, the slope of the tangent line is -8/3, right? So what can you conclude about the graph of g, knowing that g of -4 is 7/3? Function g is increasing at x equals -4, because the slope of the tangent line when x is equal to -4 is +7/3. So we have a positive slope for our tangent line. Is g of 6 minus g of 4 positive or negative? So we are positive slope, and it's even more positive, so it's increasing at an increasing rate. So we're accelerating, so this should be positive. So I guess, yes, that would be positive. Is it possible to find g of 2 from the graph? No, we can only find the slope um, um, of the graph at 2. We can't find the y value exactly from this, just the slope. It could go, there could be infinitely many curves that are, quote, parallel to each other that pass through different y-intercepts. So we would need another point on the graph to be able to figure that out. More about that when we get to maybe like chapter 4. We'll talk about that, but no, we we would need a point on the graph. And some information that we don't really have right now. So, all right, let's look at number 77. H of x is equal to the absolute value of x plus 7. C is equal to -7, so I'm at the cusp. Use the alternate form of the derivative to find the derivative of at x equals c. If it exists, it's not going to exist. We'll try to find it, but this is going to be limit as h prime of -7 is limit as x goes to -7 of absolute value of x plus 7 minus absolute value of 0 over x minus a -7, x plus 7. So this is h prime of -7, limit as x approaches -7, absolute value of x plus 7 over x plus 7. So this is a piecewise defined function that when x is less than -7, this will be -1. And when x is greater than -7, this is going to be +1. And there is no answer at -7 because it's undefined. Undefined when x equals -7. So not h of x is not differentiable at x equals -7. And there is a, it's called a node in the graph there. It comes to a sharp point in the absolute value function. All right, let's look at 78. F of x is absolute value x minus 6. C equals 6, exactly the same problem here. So let's do the work for it though. F prime of 6, limit as x approaches 6. Absolute value of x minus 6 minus absolute value of 0 over x minus 6 is limit as x approaches 6 of x minus 6 over x minus 6. And this x approaches 6 of piecewise defined function -1 when x is less than -6, +1 when x is greater than, not -6, 6, greater than 6, and undefined when x equals 6. So again, we have this graph that looks like this. I didn't draw it last time, but it looks like this. Just this is at x equals 6 this time. X is 6. And so this limit doesn't exist. So the limit does not exist. F of x is not differentiable at x equals to 6. Again, this is a node in the graph that makes it not differentiable there. All right, let's look at 79. Fx is equal to x plus 4 to the 2/3 power. All right, this is going to be a graph that looks like this. So they gave it to us. So there's a cusp here. It makes it not differentiable at -4, but it's differentiable everywhere else. So looking at the graph there, it's differentiable on -infinity to -4 union -4 to infinity, not differentiable at x equals -4 because of a cusp in the graph. Number 80. So we're given the graph here, and we are differentiable on -infinity to -2, union -2 to 2, union 2 to infinity, not differentiable at x equals -2. It's a vertical asymptote, or x equals 2, also a vertical asymptote. Finish up here with 89. And find the derivatives from the left and right of x equals 1 if they exist. And then is the function differentiable? So if f of x is equal to piecewise defined x minus 1 cubed, x less than or equal to 1, x minus 1 squared, x greater than 1. I have a function to try here. So limit as x approaches 1 from the left of f of x minus, stick 1 in there, 0 over x minus 1 is going to be limit as x approaches 1 from the left of, then one of those cancels, x minus 1 quantity squared, and then stick that in there. That gets close to 0. 0 squared is going to be 0. Limit as x approaches 1 from the right is going to be x minus 1 squared minus 0 over x minus 1 is limit as x approaches 1 from the right. X minus 1 is also 0. And so coming to the same value from the left and the right, at x equals 1, let's just make sure that from the left and the right, we would be approaching the same point, 0, 0. And we are. This gets close to 0, 0, and this gets close to 0, 0. So same y value, same sloped value from the left and the right. So yes, f of x is differentiable at x equals to 1, f prime of 1 equals 0. All right, that's it for this video. We'll come back next time and talk about 2.2. See you for the next video.